Good day, learners. Welcome to Technical Sciences lesson. My name is Zamisile Mdima. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. So learners, today we are continuing with our revision section whereby we are taking a look at the past question papers, at the possible questions that they could ask us by reminding ourselves of all the content that we've covered. So specifically today we're looking still at mechanics revision since term 1 is covering mechanics. But specifically today we are looking at MCQ question, which is your multiple choice questions, as well as your scale drawings. So by the end of today's lesson, I want you guys to be able and be comfortable in answering and mastering the skills behind answering your multiple choice questions, as well as how to best utilize your scales so that you draw your drawings in scale. Okay, whichever scale that is presented to you, or in circumstances whereby you are the one that needs to work with the scale of your preference. Okay, so let's get started. As we said, the main focus today is the mechanics revision. We're going to be looking at the multiple choice questions. We're going to be looking at the long questions. We're going to be doing problem solving strategies and giving each other hints on how best we can answer the questions that are provided to us regarding mechanics. Okay, so our prior knowledge is still all the content for term 1. Okay, so in summary, it is the vectors and scalars. By knowing the graphical representation of vectors, because vectors needs to give us magnitude as well as direction. We have to know the kinds. By now we need to know the kinds and the types of forces that there are, your types of the contact and the as well as your non-contact forces. By now we should know sign conversions, which is using your Cartesian coordinate system, your compass directions, your bearing, whichever way that is presented to you, should be able to utilize it to your best. And then your graphs, knowing the difference between the direct proportional graph and your indirect proportional graph by looking at the relationship of the two variables, your dependent variable, your independent variable as well. You have to be now knowing a difference between a collinear and a coplanar by knowing how to define them, by be able to see and that this one is a collinear and this one is a coplanar vector. By now we should be able to determine the resultant force by using various methods. That is your Pythagoras theorem, that is your head to tail method, that is your parallelogram law of forces. Okay, resolution of force into vertical and horizontal component. Okay, which one should we be using? Which one is a vertical? Which one is a horizontal? Understanding that your vertical is your y and your horizontal is your x, as well as by now we should be knowing how to calculate your frictional force. Okay, whether it is a static frictional force, whether it is a kinetic frictional force, we should be able to know how to calculate it and also apply it on our daily lives, knowing the importance of frictional force in our daily lives. Okay, so this is the prior knowledge that by now we do know. From the previous lessons that we've done, we've covered each in detail, but today we're just looking at the past question papers. Okay, now let's begin with our multiple choice questions. Okay, on your question 1.1, that is, it is saying a physical quantity with only magnitude. Okay, now the skill into answering your multiple choice questions is that there are always going to be two distractors. You need to get them out of the way and then you deal with the other two. Remember, only one answer is correct. So the other one will be a slight distraction, but it's not really a proper answer. So you only have one proper answer. Okay, so a physical quantity with only magnitude, you should know what it is because that is a definition that is provided to you. Which one is it? Is it A, a force, B, a vector, C, a scalar, D, acceleration? One easy way of being able to answer this question is by being able to define all the terms that are there so that you see which one best fits the description that is provided to you. So a force is a push or pull. A vector is a physical quantity with both magnitude and direction, so it doesn't fit. And then your scalar is a physical quantity with only magnitude, okay? Acceleration is the rate of change in velocity per unit time, okay? So the one that best fits perfectly is your C, which is your scalar quantity. So by definition, scalar quantity is a physical quantity with only magnitude, okay? So we're going to circle it here so that it is easier and visible to you. Question 1.2. A point is acted by two forces in equilibrium, okay? Understand the statement that is given to you before you jump into answering this question. The key word here is equilibrium, okay? We need to know what equilibrium means. So equilibrium means that the forces that are acting into that specific object are equal. So they are cancelling themselves out. They are cancelling each other out, resulting to what? To 0, okay? So the forces, now that you understand what equilibrium means, so a point is acted on two forces in equilibrium. Okay, so no force is bigger than the other. The forces have, is it A, have equal magnitude and direction, have equal magnitude but opposite directions. C, acts perpendicular to each other. D, acts in the same direction. Okay, so now when they are in equilibrium, so I'm going to just draw. This is a box, even though they didn't say that it is a box that is provided to you. And then we've got a force this side and a force this side. When an object is equilibrium, it means that the forces on either side are equal. Okay, so the one answer, have equal magnitude and direction, it's a no. Have equal magnitude and opposite directions, yes. So the correct answer is your B, because not that they have to be acting perpendicular to each other, no. They won't be in equilibrium in that way. Act in the same direction, they won't be in equilibrium that way. Instead, the resultant force will add up, resulting into a bigger force that is pulling, or rather pushing, the actual point that it is acted on. So correct answer here, it is B. The forces have equal magnitude, but they are acting in what? In opposite directions. Okay, maybe let's give them the magnitude. So take into consideration, maybe this F1 is equals to 10 newtons. The other one will also be what? F2 is equals to negative 10 newtons. This negative indicating that it is in an opposite direction as compared to the other one. Okay. Question 1.3. Which of the following contains two vectors and one scalar? Okay, this one is a very nice one because it challenges us to know the physical quantities that we consider as scalars and the physical quantities that we consider to be what? To be vectors. Okay, remember these are two different ones. So the one thing that you have to do on this one is determine each physical quantity that is presented to us so that you classify it as a vector or scalar, because we're looking for an option that is providing two vectors and one scalar. Okay, now let's get down with it. A distance is a scalar. Acceleration is a vector. Okay, why are we saying it is a vector? It is a vector because when you're accelerating, you can slow down, allowing a negative, or rather less movement into that direction. So we need to say it is a vector because it gives us magnitude as well as what? Direction. So this one is a vector. Speed is a scalar, okay, because I could be speeding, but I don't really say in which direction I'm speeding at, okay? So this is a scalar. And then we go on to the second one. We determine each by each whether it is a scalar or it is a vector. We categorize it. Displacement, this one is a vector. Velocity is a vector. Acceleration is a vector. Okay, moving on to option number C, and then distance is a scalar. Mass is a scalar. Speed is also what? A scalar quantity. Okay, the last option provided to us, displacement is a vector. Speed is a scalar. Velocity is a vector. Okay, and then we go back to our question and say, what is it that is required of us? Which one of the following contains two vectors and one scalar? Okay, option A, we've got two scalars and one vector, so it can't be the one. Option B, we've got vectors only, so it can't be the one. Option C, we've got scalars only, so it can't be the one. But option D, we've got two, sorry, this one was supposed to be a vector, not velocity. We are repeating the velocity that they've provided to us. Okay, so this one is a vector. So with option D, you have two vectors, just like the question wanted, as well as one scalar. So the correct answer is option D. So the key here, learners, is that you need to be able to know which physical quantities can be categorized as vectors and which physical quantities can be categorized as scalars, okay, so that we are able to answer the question properly, okay. Question 1.4, two forces act on the same point. What should the angle between them be so that a maximum resultant is obtained? Okay, let me read the question for the second time. Two forces are acting on the same point. Okay, what should be the angle between them so that the maximum resultant is obtained? Okay, should it be 90? Should it be, sorry, let's start from the top. Should it be 0 degrees? Okay, so what they've given us are options provided, giving us direction by using bearing. Okay, so option A is saying 0 degrees. Option B is saying 90 degrees. Option C is 120 degrees. Option D is 180 degrees. Remember how you use your bearing. Yeah? Let's just remind each other, where is the reference point? Where do you start calculating? And in which direction do you start calculating? Okay, so the first thing you do is that your north in your Cartesian plane is regarded as your what? As your reference point. So here is your north. Here is your 0 degrees. Here is the point where you put your protractor in. Okay, and then you start reading in a clockwise direction. Okay, so that means if we make north a reference point, meaning it is 0 degrees, okay, then this makes it, this point here, and 90 degrees. This makes this point in here to be 180, because now it is a straight line from there to this side. Okay, so making this other point, which is in your westerly direction, to be 270 degrees, and making your reference to be what? To be 360 degrees. So when both the forces are acting at one point and we want to have the maximum, that means they have to be going in the same direction. Okay, if they are acting at 90, they both need to be there. Okay, so there shouldn't be an angle in between them. Why are we saying that? So that when this, I'm going to make this object a box. Okay, if one person, because there are two forces, if one force is actually providing a pushing kind of force, and the other one a pulling force. Both these forces are acting at a point, which is your object in here, okay, object of interest. However, both the forces are in the easterly direction, okay. Meaning, if we had to draw a vector diagram, we will draw them like this. Let's give them the sizes. Let's assume that F1 is equals to 20 newtons, and assume that F2 is equals to 30 newtons, okay? And they're also acting in one direction because they're acting at a point. So, question is, what should be the angle between them so that we get the maximum resultant, okay? So, if these ones, if we want the resultant, remember what we used to do? We said F1 plus F2. Why do we do this? Because a resultant force or a resultant vector, it is a single vector that has the same effect as two or more vectors that are acting together, okay? So this one will be your what? Your 20, and this one will be your 30. Be reminded that both of them, I'm giving them a positive sign because they are in the same direction, okay? In this case, there's no angle between them, okay? They're going to be giving us what? A resultant of 50 newtons. 50 newtons to the east. However, if I split them, the other one is acting in that direction, and the other one, here is my same box, here is my 30, which is my F2, which is equals to 30 newtons, and here is my 20 acting into the western direction. This is my F1 is equals to 20. That means the F2 will be given a positive sign because it has a bigger magnitude, and then your F1 is going to be what? Negative. Because now a force is a vector, and vectors have to have magnitude as well as what? Direction. And in this case, they are in opposite direction, meaning that they have a bearing of what? Of 180 in between them, okay? Because they are in a straight line. Now, what's going to happen is that your resultant in this case will therefore be FR is equals to, then what? 30 plus into negative 20, which will give you a resultant of what? Of 10 newtons, okay? Even if it's to the east, but the magnitude of the resultant is now smaller, okay? So now, what do we have to do so that we get the maximum resultant? There not need to be an angle in between these forces. So they need to be acting in the same direction so that when they are acting in the same direction, we are able to add them, okay? Because it is a single vector that has the same effect as two or more forces that are acting on each other, meaning that it is the sum of all the forces that are acting onto that specific object. So the correct answer here was that there has not to be an angle in between these forces, but the angle should be 0, okay? Meaning it has to be in this scenario, meaning there has to be in one direction. So the correct answer in this case is your A, which is 0 degrees. 1.5, it says two forces, 4 newtons and 11 newtons, they're acting on a point. Which one cannot be the resultant? Okay, remember, resultant is a sum of all the forces that are acting together, meaning that you need to add them, okay? Because now we're looking for that single vector that has the same effect as the all other ones combined, okay? So now, is it A? We are provided 4 options. Is it A, 4 newtons? Is it 7 newtons, which is your option B? Is it your C, which is your 11 newtons? Or is it your D, which is your what? 15 newtons. Okay? Don't forget to read your statement properly. Because now in your question, it said, which one cannot be We are not looking for the resultant, okay, but we are looking for the impossible, that what can never happen, okay. So you're looking for the smallest number, okay, because now the resultant will be the sum adding all of the forces, so it can never give you the smallest size or smallest magnitude in this case, because we're given the magnitude only, okay. So now, can it be your option A? Can it be your option B? Can it be your option C, or rather D? So the correct answer in this case is your option A, okay, because this is we're talking about a single vector that has the same effect as all the other ones combined, meaning we have added all the other ones, so it can never be the smallest number, okay. So this, it can never be, it cannot be a resultant, okay. Question 1.6, identify a contact force. Again, you need to know what is a contact force. You need to remind yourself which one are non-contact forces, okay, because these are kinds. And in your kinds, we've got the types, okay. But before we even get into the types, what is a contact? When we come into contact with somebody, we have that physical contact with each other, okay. So are you in the contact forces? That means there's a physical interaction with it. I am moving my pen up and down, you know, I am shifting the car to the left to right, I'm pushing it, okay. That means I'm physically touching the car. That means there's a physical interaction. It's a contact force. However, if it's your non-contact force, it's your gravitational force, okay. It's your magnetic force, okay. That means that there is a force that is being applied or being exerted into the object. However, it is not physical. There's no physical interaction. For example, if I let this pen go and decide I don't want to touch it no more, it won't fly out the window, it won't go through the door, or it won't go up, but it will just automatically go down. Why? It's because the gravitational force has been exerted onto it, okay. Therefore, pulling this object downwards with a gravitational acceleration of 9.8 meters per second squared, okay. So in this case now, I was trying to just elaborate where we are, but now not deviating from the question. It says identify the contact force. Is it a windmill turning? So when you're turning the windmill, it's like there has to be wind that is provided so that there is some proper, in cases whereby we use the windmill, is whereby we're trying to get the water from underneath the ground. Is it the gravity? No. We've already counted gravity as a non-contact force. Electricity? No. Magnetism? No. I can pull in magnets, you're trying so hard to pull these ones, the north to south ones, or the north to north, or the south to south, but you find that there is going to be that force, the magnetic force that will be in there. So the correct answer in here is A, which is your windmill turning. .7, you've got dash 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 is a non-contact force. Is a non-contact force. I've already given you examples of a non-contact force, okay. A windmill turning, nah, we've already classified it as a contact force because you need to come into physical contact with it. A magnet pulling a paper clip, because we're not physically touching. So here's a magnet, and then you rub your paper, okay, and then you try to touch your pieces of paper. You'll find that they will attract. Why? Because the positive side of the magnet will be attracted to the negative side of the paper, because the opposite charges attract each other, okay. Force used to open the door. You have to physically interact with the door so that you are able to open it. So that one is considered to be what? A contact force used to shape clay. You need to use your hands to shape the clay into the shape that you want, okay. So you are touching, there is a physical interaction between the molder and the clay. So that one is a contact force, but we are looking for a non-contact force, Okay, so the correct answer in here is your B, okay, which is your magnet pulling a paper clip. Okay, so you would realize that by doing these multiple choice questions, we are also looking at the all-round content that we've covered. We did talk about forces, but now we want to be tested, or we are tested, in terms of, did we understand this type of forces? Okay, so that we are given different types and we are able to classify them, hence getting the proper answer or choosing the correct answer. Okay, not underestimating the importance of reading the question. What is it that is they want from you? Okay, so what is the question saying? What are you responding to? Okay, because that is important. 1.8, there are 5 houses in the street as indicated below. There is house A, B, C, D, and E. So they say you live in house C. Your home is house C. What is your position to house E? So how would you explain to us where you are when you are at house C? Somebody is looking for the directions to your house. Where would you say you are? Okay, because now you live in house C, you're going to make where you are a reference point, meaning that where you are is going to be considered as 0. Okay, so here's my C, and C, this is our home, and this is our reference point, so it's 0 degrees. Okay, then when you start counting, because now the distance between houses is given. So between house C and D, it is 20 meters. Between house D and E, it is 20 meters. And we are being asked whether, what is your position to house E? Is it A, 40 meters away? Okay. B, 20 meters away? C, 60 meters away? Or D, 80 meters away? Okay. This is where we are in relation, or what is your position to house E? 20, 40. Okay, so the correct answer is we are 40 meters away, because you had to consider that your reference point will have to be your house, then you start counting. Okay, so the correct answer in here is very easy. It is A. It is an obvious one. Question 1.9, it says a boy must walk 100 meters to buy milk from the shop. Okay, he takes 2 minutes to walk there. How long in seconds will he be out of this house? Okay, now because now you're given your time in minutes. Okay, this is just pretty much a conversion. Okay, now what is 2 minutes in seconds? One, you need to realize that 1 minute is equivalent to how many 60 seconds. Okay, but now if you have 2 minutes, therefore now you've got 60 and another 60, and then this is giving you what? 120, giving you an option of what? Of A. Okay, for this one you do need to do your calculations prior choosing the appropriate answer. Conversions it is. Question 1.10, if it takes a car to move 50 meters in 3 seconds, what is the speed of the car in meters per second? Okay, so with this one I always say you can use your DST if you feel like you've forgotten, okay, which formula to use, your DST. Okay, I always say use DSTV, but there's no V in there. However, now you're looking for the speed. For the one that you want, you close it. You're looking for speed. So if I close S over there, which is representing speed, therefore I'm left with distance over time. So therefore speed is therefore distance over time. Therefore, what is my distance? Distance that I'm given is 50 meters. And the time that I'm given is 3 seconds. Therefore, you put this in your calculator. You're like, okay, what is my 50 divided by 3? It's giving me 16,67. If it is rounded off, in the next 2 decimal places. Okay, so meters per second, because in your numerator you've got your meters, in your denominator you've got your seconds, giving us meters per second. Okay, so that is how the meters per second units, SI unit, came about. Now we look at the options that are provided. Is it A? Is it B? Is it C? Or is it D? Then we say our correct answer, or the answer that we've calculated, is on what? Option A. Okay, so that's how easy it is. So with every multiple choice question, there is required to be some remembering or some recalling of the information that you've done. Okay, but also not forgetting how to work it out so that you are able to choose the correct answer. Do proper calculations so that you are able to choose the appropriate answer. Okay, let's move on to the next one. We're looking at question 2 now. We are reminding each other to do, or how to use rather, scale. When we are giving a scale, how do we use it so that we are drawing our drawings in scale? Okay, our drawings are in scale. So with question 2 is saying 2 forces, 40 newtons in the x direction, okay, and 30 newtons in the y direction, act on the same object. Okay, first question 2.1.1, is force a vector quantity? Yes or no? So yes, it is a vector quantity. But why would you say that? It goes back to you understanding what is a vector quantity. Okay, so let's go to a clean page so that we are able to answer it nicely. We're at 2.1.1. We will ask if it is a vector quantity, yes and no. The first thing we should do is choose one option. Yes, it is. Okay, and why do we say that? It's a physical quantity. With both magnitude and direction. Okay, very, very important in acknowledging this. That means we represent this a force by using arrows. So there's an arrowhead and there is the length of the arrow. So that length of an arrow is signifying or is telling us about the magnitude of the force. Then the arrowhead is telling us about the direction of the force. Okay, let's go slightly back so that we see the next question. 2.1.2, draw both forces on the same Cartesian plane, and then they gave us a scale. 10 millimeters is to 1 Newton. Okay, so this is very important. Remember, I like saying that a scale can help us to enlarge or to reduce our drawings. Okay, so in this case, we need it so that we are able to draw it in a piece of paper. Okay, so that we have that 40 newtons drawn in a piece of paper. So 10 millimeters is equivalent to what? To 1 Newton. Okay, I like putting it there first so that 10 millimeter, in fact, let me just write it with red so that it just stands out, and then calculations can be written in black so that we can know. So we have 10 millimeter is to what? Is 1 Newton. Okay, so what is the forces that we are given? We are given 2 forces. The first one is 40 newtons in the x direction. Okay, 40 newtons. How much should we have? We have, in this case, 40 Newton, and then we want to know in millimeters how much should we draw in a piece of paper. Okay, and I'm putting it like this because this is what I want to know. How much, or the length that I should put in millimeters. Okay? And I'm putting a 40 newtons here so that the units, the SI units that are the same, are in one side. And the ones that I want are in one side as well. So what does that mean? This newton will cancel that newton. That's the first thing you need to do. Because now you can't have two SI units in one, in trying to resolve one problem. Okay? So now we are left up with millimeters only, which is, that means that our answer will have to be in what? In millimeters. Okay, so we cross multiply. We call this method a cross multiplication. Okay, you would just put a cross in here like that, so that this tells me that x times 1, I'm not saying 1 newton, I'm saying 1, because now that newton has cancelled another newton. So this is going to be x is equals to 10 millimeters multiplied by 40. So it's going to be 400 millimeters. Okay, that means that I need to draw 400 millimeters. Okay, and then I go to the second one. Still doing the same thing. I take my scale, I'm saying I'm given 10 millimeters is to 1 newton, and on the second force, just to go back a little bit, I'm given 30 newtons in the y direction. So newtons, I can't put it next to the millimeters, but I need to put it next to other newtons. Okay, I can't have you say to yourself, okay, this is what I want. I'm going to put an X because I'm trying to figure out how much millimeters I should be putting into a piece of paper. Okay, so we cross multiply, but before we do that, we cancel out the units that are the same. Newton will cancel another newton, and then I can cross multiply in peace. Okay, 1 times x is going to give you x is equals to, then 10 times 30 is going to give you 300 millimeters. Okay, so this is what we have. And then you take your ruler. In a Cartesian plane, you are told, okay, this, in this case, you have your x and then you've got your y. Just so that we put it nicely, let's just go back that the 40 newtons was in your x and then the other one was in your y. So we are always putting x's, so just put y in here so that we know the difference between the two. This is our y. So it is very common that people were always trying to solve for x and we make the unknown x in everything. Okay, so in this case your y is in your vertical, okay, and then we've got your 40 in there. In your Cartesian plane, let me just draw my Cartesian plane out nicely. That is your Cartesian plane. Obviously, you indicate that this is your y and that is your x. Okay, so you take your ruler, you measure out nicely. So I'm going to make mine to be going in what? In hundreds. Okay, 1, 2, 3, 4. Let's make it on the other side. 1, 2, 3, 4. Okay, so given this to be what? To be in millimeters, and given this to be in what? In millimeters. That means that you use your millimeters in your ruler. Okay, you said this one, let's just write numbers using a different one. This will be point of intersection, will be your 0, and then your 100, your 200, your 300, your 400. Okay, same thing goes on this side. It's your 100, your 200, your 300, and your 400. Okay, and then you measure it nicely by your x. It should be 400. From 0 point, you just go straight up until you reach 400 using your ruler, okay? And then where you're ending, there has to be an arrow, okay? Why are we doing this? Let's just go back to the question. Draw both forces on the same Cartesian plane, okay? So that is why we are writing them in the same Cartesian plane. Then that is your x, it's 40 millimeters, sorry, 400 millimeters, that is. Your y has to be your what? Your 300 millimeters, okay? 1, 2, 3. Using your ruler. So that means it has to be an exact 300 millimeters, okay? Not that you are, because my ruler just disrupts the whole drawing in here. So that is why I'm showing you that that should be in millimeters. That should be exactly 300 using your ruler so that your drawing is in scale. Okay? So, let me just write it slightly bolder so that it is more visible. Okay? So you don't leave it like this. You therefore label. Okay, this one is let's make this one to be F1, which is equals to the first one that was equals to what? And then we've got 40 newtons and 30 newtons. So you've got F1, which is 40 newtons. And then F2, which is your 30 newtons. Okay, let me explain this. You do all of these calculations so that you get the correct measurement using your scale, what you should be drawing, or the magnitude of that line or of that arrow that you should be drawing. So we do know from this case that our 40 newtons has to be on paper what? 400 millimeters. And we do know that our 30 newtons on paper needs to be what? 300 millimeters, because that is the scale that we've been given. Okay, hence this is how we have done it. Okay, so this is how you utilize your scale to figure out the magnitude of how much you should be drawing on paper using the scale that is given to you. 2.2 goes on to say a worker is pulling a concrete block due to east. And then they give us, reminding us about the compass direction in there, okay, which is very good. And it says a worker is pulling a concrete block due to east, and then with a force of 80 newtons, while the other worker is pushing the same block to the east with a force of what? Of 70 newtons. Okay, now 2.2.1, it gives us a scale again. That means we need to use the scale. Find the resultant of the two forces using the scale diagram. Okay, so we have to draw these in millimeters because this is what we've been given in a scale that we've been given. The scale is saying 10 millimeters is equivalent to what? To 20 newtons. Okay, and we've got these two forces. So, but now we want to draw the scale diagram, but we don't want to write or draw the 70 newtons. How much should we be drawing in a piece of paper? Okay, that is the reason behind us utilizing the scale. So let's get down with it. We've got a 10 millimeter is to 20 newtons. 10 millimeter. So which question are we doing? We're doing 2.2.1. 2.2.1. 10. Okay, let's write it neatly and nice. So we've got 10 millimeter is equivalent to 20 newtons. Okay, let's start with the first force that is acting into this box. We've got a 70. Okay, let's start with an 80 because it's bigger. Say, okay, I can't just put my 80 anywhere. Oh, because it has an SI unit of newtons, it has to be alongside with another newton. Same units are together. And what am I looking for? I'm looking for the size or the length of this in millimeters. Okay, that's inappropriate to do it. Cancel out the newtons on either side, and then you put a cross so that you remember that you're doing a cross multiplication. X times 20 is going to give you 20x, which is equals to 10 times 80 is going to give you 800. But now you're having just one SI unit, which was your millimeters. Okay, you divide by 20. You divide by 20. So this 20 is cancelled by this 20, and you say, okay, what is my 800 divided by 20? It's going to give us 40. So x in here is equals to 40 millimeters. Okay, and then you do the next one. That means for the first force, you have to withdraw, instead of drawing 80 newtons, you're going to be drawing 40 millimeters. Okay, you do your second one and you say my 10 millimeters is equivalent to what? To 20 newtons. And then I have the next one, you have your 70 that is given to you. So therefore now you have what? 70 newtons in the side, and you want to find out the length of this arrow that you should be drawing. Okay, you put an X in there. Okay, first things first, you can tell the units that are the same. That is, your newtons is to newtons. Okay, and then you have your 20x, because now x multiplied by 20 is going to give you 20x, and then you're going to have equals to 700 millimeters. Okay, but now we're not done, because we're not looking for 20x, but rather we're looking for x. So it's going to be divided by 20 on both sides. That cancels that. X is equals to 35 millimeters. Okay, so instead of having this 70, we're going to have draw the length of what? Of 35. Okay, because now we haven't answered the question. We wanted to find out the length that we should draw in a piece of paper. Remember, both these forces are acting in an easterly direction, so they're moving in the same direction, meaning both of them should be in the same direction, even when we are using our scale diagram. Okay, so here's my 40. I'm just going to try. Okay, 10, 20, 30, 40. Okay, that means here you've got your millimeters. Using your ruler, you place it and you just draw 40 millimeters. Okay, so this is your 10, making this your 0, 10, 20, 30, no, it's not, 40 is not in here. Okay, these are your millimeters using your own ruler. Okay, and then we're using a head to tail method, where the head of the other vector is, or the other force, we join the tail of the other one. Let's just use a different pen so that you are able to tell which one is which. You still have 10, 20, 30, 40. Okay, so this is your 10, this is your 20, this is your 30, and this is your 40. Mind you, the one that is 70 is 35, so you don't need to reach a 40. So your 35 should be halfway through. Nicely done, because it is half of that. Okay, so this is our scale drawing. we've utilized the scale, and then this is how we moved, okay? And then now we need to show the resultant of the two. So this is in millimeters as well. So everything in here is in millimeters by using our ruler, okay? So now your resultant will therefore be moving from this side to that side. Okay, don't forget, every drawing needs to be labeled. Okay, so this is your F1, making this one to be F1 is equals to 80 newtons. Okay, you don't write that 40 millimeters. This is where you find out the length of what you should be drawing. Okay, and then this is your F1 and this is your F2, which was initially what? 70. So here's your F2, which is equals to 70 newtons. Okay, so this one is therefore going to be your FR, which is your resultant force, which is going to be equals to, let's calculate it. We're going to say F1 plus F2. Remember, both these forces are going in the same direction, so both of them has to be positive. So it's going to be positive numbers all the way. So that means that you're going to have your 80 plus your 70, which is going to give you your positive 150 newtons. Because initially you had chosen the easterly direction as positive, because both of them are going in the easterly direction. Therefore, your answer is positive, and therefore also because your resultant force is a vector, then it is 150 newtons east. That is how easy and simple it is. Next question is saying, write down the magnitude and direction of the force that must be applied on the concrete block to make the resultant force equals to 0. So when the resultant force is equal to 0, it is when all the forces that are acting onto the block are in equilibrium. So there are any other forces bigger than the other, they have equal magnitude. Okay, so let's go and see what should be the magnitude and the direction of the force that must be applied to the concrete so that we make a resultant of what? Of equals to 0. So you already have a resultant that is moving in the easterly direction. Okay, so the block is just moving in the easterly direction. However, if we wanted to make the resultant to be 0, that means all the forces should be in equilibrium. In equilibrium means all of them should be equal to each other in magnitude. Because now we have a 150 in the east, that means our FR, which question is that? Let's just go back a little bit, 2.2.2, 2.2.2. It has to be 150 to the west. Okay, because now it is, if it's 150 going to the right and 150 going to the west, these are equal in magnitude, and what they will do is that they will cancel each other out. Let's put it into calculations just to prove it. So FR is equals to F1 plus F2. However, now they are equal in magnitude but they are in opposite direction. That means one of them needs to have the negative sign. You can give them either or. It could be the ones that are on the F1 or the F2 side, because both of them are equal in magnitude. So we're going to say 150 plus into negative 150. 150 minus 150 is giving you 0 newtons. Okay, so now it is in equilibrium. Hence we said 150 to the west. Okay, question 3, we're continuing looking at the scale drawing. Okay, definition of the two terms is very important. Okay, it's just the sum up of all this chapter in just 2 words. What is a scalar quantity? What is a vector quantity, that is. So vector, physical quantity that has both magnitude as well as what? As well as direction. Scalar has got only magnitude only. Okay? Let's just write it down so that you remember. Keep, this is our solution page. Vector, physical quantity, with both, okay? And direction, whereas the scalar physical quantity with magnitude only. Okay, next question is about the scales. Draw a system of axes for each of the following and represent the vector given on it. Choose an appropriate scale and write it down next to your answer. Okay, so in each of the following, so we draw a system of axes for each, not all of them in one Cartesian plane coordinate system. So we just each separate system of axes. Okay, so for 3.2.1, let's use the scale that has been provided to us. (3.2.1), what are we given? We're given 10 millimeters represent 10 kilometers. 10 millimeters represent 10 kilometers. Okay, so what do we do? What is it that we are given? So 200 kilometers in an easterly direction. 200 kilometers, that means same units in the same place. 200 kilometers, I'm going to say east so that we don't forget. What is it that are we looking for? We're trying to, we are looking for the length that we should be drawing in a piece of paper. So we're representing it by x in this case, and then kilometers will cancel kilometers, and then we put a nice axis so that we remind ourselves that we are cross multiplying, and then x, this is 10x, is equals to 10 times the 200 is going to give us 2,000 millimeters. Because why did we cancel kilometers? Because in one problem we can't have two separate SI units. Okay, so what is it that we're looking for? We're looking for a representation of the length in millimeters. Okay, so that divided by 10 and then divided by 10, because we're looking for x, not 10x, so that 10x cancel each other out and we're left with 200 millimeters. Okay, so in the easterly direction, you draw your Cartesian plane. Okay, I hope that is straight enough. Remember, this is your north and this is your west. This is your east. Okay, and this is your south. Right, and then using your ruler, you measure out nicely your 200 millimeters. Okay, so I'll make this to be my 50, my 100, okay, my 150, my 200. Okay, so I'm there. Okay, it could continue to be a 300 depending on the piece of paper that you have, but don't forget that this is an easterly direction, and then that means that this vector has to point in an easterly direction. There I am drawing my 200 okay, and there I am labeling it with the original force that was given to me. Okay, so this is what? This is 200 kilometers to the east, because everything should be properly labeled. Okay, so that's how easy it is to use your scale so that you are able to write proper scale drawings. Okay, if you are able to use the scale that is presented to you. The other one is 300 kilonewtons northwest. Okay, let us remind each other. Where is your northwest? Where is that compass direction? This is your north, this is your east, this is your south, and this is your west. Okay, so when it is northwest, that means that it is in the fourth quadrant. In there, this is your northwest. That means that vector that you should be drawing here, the length of this line should be going into that direction, not any other. Okay, and then that is it. That's how simple it is to work with scales and to draw in scale. Okay, now here's what I want you to be able to do for me as well. Just like we did together, we've tried, or we started with multiple choice questions, mastering the skills of how to answer the multiple choice questions. So there is yours that I want you to try out. After practicing together, this is what I want you to do on your own. Okay, the first question goes on to say the perpendicular force. When something is perpendicular, force exerted by the surface on an object that touches the surface. Okay, is it A, your tension, B, your normal, C, your gravitational, or D, your compressive? So those are the types of forces that are given to you. Once you know how to define, remember what we said, once you know how to define the force, one, you're going to be able to draw it correctly. Number two, you are going to be able to calculate it correctly. Okay, so definitions are important, because without a definition, you won't be able to draw correctly. You won't be able to calculate correctly. Okay, 1.2, the force parallel to the surface, okay, that opposes the motion of the object and acts in the opposite direction of the motion of the object is it tension? Is it normal? Is it frictional? Or is it compressive? Okay. 1.3. The resultant of two forces, F1 and F2, is Fr. It's a statement. Now, which one of the following vector diagram correctly represents the relationship? So is it option A? Is it option B, C, or D? Okay. Now, in these forces, are you able to draw forces correctly? This is what we're trying to test out in this question. 1.4, the equilibrium forces is the vector sum of all the forces acting onto the body, the algebraic sum of all the forces acting onto the body, the resultant of all the forces acting on the body, or is it the negative of the vector sum of all the forces that are acting on the body? What is an equilibrium force? How do we find this equilibrium force is what we're testing you on. 1.5, for a book falling downwards. Okay, the book is falling downwards at a constant velocity. The correct force diagram, remember we've got a force diagram and we have a free body diagram. In this case, it is a force diagram because the object in concern or in question is represented by a box. Okay, now we're testing you, are you able to draw the forces correctly? Okay. Question 2 is going to say, 2.1 is saying, what type of a vector is 35 meter east? Is it a displacement? Is it a velocity? Is it acceleration, or is it a force? One key hint there is that you take a look at the units that are provided to you. So you give it in meters, okay? So is it possible that it could be acceleration, knowing the SI unit for acceleration? Is it possible for it to be a force, to be a velocity, to be a displacement? I have no idea. 2.2, what type of a vector is 300 Newton west? What type of a vector? Okay, hint again. You look at the SI units that are provided to you. What type of a vector is 5 meters per second squared to the north? What type of a vector is 35 meters per second south? Okay? Question number 3. Use the two different notations to write down the direction of the vector in each of the following diagrams. Just to remind you of the different notation in which you can write direction, you can use your coordinate, Cartesian coordinate system. You can use your bearing. You can use your compass direction. Okay? So 3.1 is just a force, or rather a vector that is pointing in the north direction. So how would you represent that using bearing? How would you represent that using the compass directions? Okay. So for each of them, you give us two different notations. Okay. To end this lesson nicely, I want to thank you. And also, I want to end this lesson by a quote from Mary Peace. It says, sometimes things aren't clear right away. Sometimes things aren't clear right away. That's why you need to be patient and persevere and see where things lead. I'll say it again. Sometimes things aren't clear right away. But that's where you need to be patient, persevere, and see where things might lead. I know some things that we learned about today might not be very clear for you, but this is where you need to be patient with yourself. This is where you need to persevere and keep going, keep trying out, and then you will get it right. Okay? And then that is where you will figure out where things will lead you. And I'm definitely sure that they will lead you to success. As long as you're patient with yourself, as long as you keep on persevering, you will be lured to success. Okay? Thank you for attending today's lesson. See you next time.